Okay, section 1.2, functions. A function is a relation that assigns each element x to exactly one element y. Each x has one y value, or no single x value is paired with multiple y values. The way you might be used to checking for functions, graphically at least, is the vertical line test. If you draw or imagine an infinite number of vertical lines going through your graph, each line hits the actual graph one time. That means it is a function. As soon as you have a vertical line that hits twice, you know it is not a function. So graphically, you use the vertical line test. If, like in our example here, you're asked to determine if the relation is a function or not, you could plot the points. So 4, -1, 3, -4, 2, -1, and then 4, 3. And once they're graphed, you should be able to see that if I drew a vertical line right there, it would touch my function, my points, twice. If you look at it, you would see that there are two x values of 4 that have a different y value, and that's how you know it is not a function. So you could look at it graphically, or you can make sure that every x has exactly one y value, and the 4 has two y values in this problem. Domain and range. Domain is the input values, which is typically x values, and range is the y values, output, which is typically y. We say typically because if you're doing like a time and distance problem, they might use t for time instead of x, right? So the nice part about domain and range is that it pairs up alphabetically. If you write D and then R, because in the alphabet D comes before R, and then X and then Y, because alphabetically X comes before Y, domain goes with X, they come first in the alphabet, and range goes with Y, they come second in the alphabet. So that's one way I use to help me remember which goes with which. Domain is X and range is Y. Okay, first thing, determine if it's a function and identify domain and range. So we're going back and using some of your parent graph skills for these. So from integrated 3, parent graphs was an essential skill. You should recognize that parent graph as a parabola. The vertex is at 2, 3. Opposite the parentheses and the constant stays the same. It has an a value of 1/2, so over 1, up 1/2 on both sides. This is what the parabola would look like. That's good enough to get our answers. D for domain, R for range. Domain is the x values. If I look at the graph, it has arrows going left and right forever, so the domain is all real numbers. Range is the y values. If you look at the graph, the lowest this graph goes is 3, and it touches 3, so bracket 3. And then it goes up to infinity, so infinity is always a parentheses. Is it a function? If you draw a bunch of vertical lines through it, each line only hits once, so yes, it is a function. Number 2, hopefully you recognize this as a hyperbola. Locator point opposite, imagine there's parentheses around this, so -5, and then -2. That's where your asymptotes cross. This is a review of your parent graphs from integrated 3. It was an essential skill. And then it's in this corner, because it's positive. These are our positive corners. Domain, range, function. So because it has asymptotes, and again, this was -5, -2, it gets really, really close to those asymptotes, but it doesn't touch it. So a really quick way to answer for domain, it hits every number except for -5. Right? It has an asymptote at -5. It does not hit -5. So the quick way to say that is all real numbers, comma, x cannot equal -5, because that's where the asymptote is. Same idea for range. It hits every y value except for -2. So see if you can write your range in that quick way. It hits all real numbers. Y cannot equal -2. Those are the only values it doesn't touch, so that's the quickest way to write your domain and range. Is it a function? If you drew a vertical line, it would only hit once, so hyperbolas are functions. Okay. another way to do this without graphing it, well, because we're not asked for the domain and range in this one, we're just asked whether it's a function or not, so graphing it seems kind of pointless. We can, step 1, solve for y. If you get one equation, that means every x has only one output, one y, so it is a function. If you get 2 equations or more, it is not a function. You'll see what I mean when we do these examples. So solve for y. That means minus x squared to the other side. Negative x squared plus 1. That is one equation. I could plug in some x's, and every time I would get a different y value. So this is a function. Let me show you number 2. Solve for y. Add the x. So you're at y squared equals x plus 1. To solve for y, you have to square root it. And if you remember, we preached this a lot last year. When you square root, you get plus and minus the square root of x plus 1. This right here means that I get 2 answers. One x value is going to give me 2 different answers. So this is not a function. That's how you can tell once you've solved for y. Okay, so we did domain and range of graphs that you're familiar with, but what if you're not familiar with the graph? There is a shortcut. So for finding the domain, there are 2 things we have to be careful of. Only 2 problems arise when you're trying to find the domain of something. Either you can't divide by 0, so if we see a fraction and x is in the bottom, we're going to make sure we're not dividing by 0, or you can't square root a negative. And theoretically, both of these could happen at the same time as well. So we're going to make sure that the equation is not dividing by 0 and that is not square rooting a negative. So look at example 1. Am I potentially going to divide by 0, or am I potentially going to square root a negative? Well, there's no square roots in problem number 1. And I do see x is at the bottom of a fraction, so potentially I could accidentally divide by 0. So that's the one we're focusing on, and we're going to make sure that doesn't happen. If I'm not allowed to divide by 0, then the bottom of the fraction cannot equal 0. And then if we solve this, it's going to give us our domain. So even though it says cannot equal, just solve as if it said equal. 2x cannot equal negative 7. Divide by 2. X cannot equal negative 7 over 2. So remember, for domain, that means it can be everything else, all real numbers, but x cannot equal negative 7 over 2. It's also asking for the range. So for the domain, we took the bottom and said it couldn't equal 0. For the range, think about what this equation means. We have a fraction minus 3. Since the bottom can never equal 0, the fraction itself is never going to equal 0. So if it's never going to be 0 minus 3, y is never going to be negative 3. And it's as simple as whatever the constant is, that's what y is never going to equal. So for our range, all real numbers, but y is never going to equal negative 3. Since the fraction can't be 0, the equation can't be negative 3. Okay, let's look at number 2. Which of my 2 possibilities do I have in number 2? Well, I don't see any fractions, but I do see a square root symbol. Oops, I wanted that to be highlighter. So I could potentially be square rooting a negative if I'm not being careful. So if I can't square root a negative, the stuff inside the square root can't be negative. How do we do can't be negative in math equations? Can't be negative means it must be greater than 0. And can you square root 0? You can square root 0, so it's actually greater than or equal to 0. The stuff under the root has to be greater than or equal to 0. And then again, you just solve that as if it was an equal to sign. you minus the 3. 2x has to be greater or equal to -3. Divide by 2. X has to be greater or equal to -3 over 2. For domain, the way we say greater or equal to is bracket -3 over 2 to infinity, right? It has to at least be -3 halves. But it's greater than that, so it can go on to infinity. And then it wants the range as well. Well, if that's the smallest it can be, we know that when we plug that in right here, we're going to get 0. And then 0 minus 1 is -1. So our range, when we plug that in, the smallest answer we're going to get is bracket -1, and then it's going to go up to infinity. Again, it comes from the constant. Okay, lastly is function notation. This should be a really quick review. We've given you an equation on the side, and then we want you to find f of -3. So given equation f, remember when it's in the parentheses, that means x equals -3, but it's a much quicker way of writing it. So you're going to plug in -3 into your x. -3, you square first, exponents first. -3 squared is +9, 18 plus 1. The answer to 1 is 19. 2 says plug in a half, f of 1/2. No calculators, so plug it in. When you square first, you square the top, 1 squared is 1, and you square the bottom, 2 squared is 4. When you're multiplying fractions, you multiply the tops and multiply the bottoms. That's just 1/2. 1/2 plus 1 is 1.5, or 1.5, or 3 halves, however you want to write it. 1.5 is our answer. And then 3, f of a plus 1. Plug in a plus 1 to the x value. Be super careful here. Don't kill the puppies. If you don't know what I'm talking about, I'll probably mention it in class one day. You can't distribute a square. Just that step requires an area diagram. A plus 1 times a plus 1. That's a squared, a, and 1. Just that piece inside the parentheses is going to give you a squared plus 2a plus 1. Do not distribute a square. That's not how math works. But now we distribute the 2, and you get 2a squared plus 4a plus 2 plus 1. 2a squared plus 4a plus 3 is our final answer. Real quick, remember the difference. Let's just add a number 4 here really quick. If f of x equaled 19, remember that's saying the equation equals 19. So in the parentheses it's x, equal to means you set it equal to, and then you would solve. -1, 2x squared equals 18, divide by 2. X squared equals 9, and then square root, and remember you get plus or minus 3 for that answer. In the parentheses it's x. If it's equal to, you set it equal to and solve. Okay, hope you're doing well.